Hello folks, and welcome to this lesson on writing chemical reactions. Now when it comes to the chemical reaction, there are usually a lot of things that are happening. You start off with some chemicals, they do something, and then you are going to come out with different chemicals. But to describe all of this in words like I just did can be very inconvenient, and it would take up a lot of space, and it would be hard to see as well. And so chemists have come up with a different way to express how a reaction happens. So when you have a chemical reaction and you write it out, instead of using sentences, they are going to use an equation of sorts. Though there are no equal signs in this equation, unlike math. So you are going to have stuff that you start out with, which are referred to as reactants. And you are going to also have things that you end up with, which are called products. These reactants and products are going to be split with an arrow, not an equal sign, an arrow. And when it comes to writing the reactants and products themselves, you are going to have the names or formulas of them. And if you have many or more than one of reactants or products, each of these will be separated by plus signs. And so this is generally what a chemical reaction is going to look like when written down. So in general, there are three types of ways that you will write chemical equations. The first one is referred to as a word equation, where when you have your chemical equation, you are going to use the names of the compounds in place of where the reactants and your products are. The second method, which isn't really used a lot, is the skeleton equation, where instead of the names of the compounds, you use the formulas instead. Now, the skeleton equations are not used very often because it contains a little less important information compared to the balanced chemical equation, which is actually going to be covered in a different lesson. So here's an example of a chemical reaction being described. A piece of sodium is thrown into water. Sodium and hydroxide and hydrogen gas are produced. From here, some of the formulas are going to be fairly obvious. When you have sodium, that's an element. You have your periodic table to find it from. Sodium hydroxide, you use the nomenclature rules to figure that out as well. That being said, in some small cases, you have more common names for certain chemicals. Water is one of this, and water is one of the more well-known ones, and it is referred to as H2O. You aren't going to see that many common names of a lot of chemicals, but two others that do show up quite a bit are methane, CH4, and ammonia, NH3. Ammonia is different from the ammonium polyatomic ion. So this one up here has the A, and it has no overall charge. It is a molecule, whereas ammonium, so that's your NH4, that does have a charge, so this whole thing is an ion. So make sure you're being careful when this sort of thing shows up. Another chemical name that doesn't really refer to the chemicals in the formula that you might see is glucose, so that's C6H12O6, but even that you're not going to see all that much unless you're talking about biology. Another thing that you can see expressed in a chemical formula are states. For the states, you have different symbols that can be used. So S is for solid, L is for liquid, G is for gas. They are all in brackets. And the other one that you can also see is aqueous, which means that it is dissolved in water. It's in solution, and that is your aqueous. Most of the times your elements are going to be in one of these three states. Take a look at the periodic table that's in the classroom. It'll probably tell you what the states for each of the elements is at room temperature. A lot of the compounds that you are going to use are going to be in aqueous form, especially if they're ionic, but take a look at the description of the reaction itself for more details there. So let's try writing out that reaction from before. So a piece of sodium is thrown into water. So this means that you're starting off with sodium and water. These are going to be your reactants. in the word equation, you are using the names of the chemicals themselves. So you're going to have sodium plus water. And then you're going to have an arrow, and then you are going to write down the names of your products. So it's being produced, what is sodium hydroxide and hydrogen gas. So our products are going to be sodium hydroxide plus hydrogen gas. And for the skeleton equation, you're basically going to draw or write out the formulas for each of those chemicals with the plus signs and arrows as needed. So for sodium, that's going to be Na, water is H2O, and then you have sodium hydroxide, which is NaOH, and your hydrogen gas. Now from here, you can put in your symbols for your states if you are aware of them. Some of them are going to be a little bit easier. If you have a piece of sodium, it's going to be a solid. Water is a liquid. Hydrogen is said to be a gas here, and this one might be a little bit trickier, but I myself am aware that this is sodium hydroxide in solution because you've put it into water. And so there we go. That's the skeleton equation. So I'd like for you to pause the video and try this one out. Write the word and skeleton equation for this reaction. Barium chloride and sodium hydroxide are reacted to form solid barium hydroxide and sodium chloride. So we are starting off with your barium chloride and your sodium hydroxide. And with your two reactants, you are going to separate them with a plus sign. So this becomes barium chloride plus sodium hydroxide, and this becomes barium hydroxide and sodium chloride. So separate them, plus sign in between. For the skeleton equation, you are going to take all of those names and change them into symbols, and so it's going to look something like this. So you have your BaCl2 aqueous plus NaOH aqueous becomes BaOH2 solid and NaCl aqueous. Be very careful when you're checking your work. Make sure that the formulas are all correct according to the names. In terms of states, most ionic compounds are going to be in aqueous form. It will be dissolved in water. The exception in this case is your barium hydroxide, which was hinted at by the description itself, where it said it reacts to form solid barium hydroxide. So that's the end of this lesson. I'll see you next time.